Hey, geometry. Good morning or afternoon. I am doing lesson 33 today. We're starting a new one, but you have a quiz tomorrow. I want to be very clear. What I'm about to teach you is not on tomorrow's quiz. Tomorrow's quiz is over chapter 30. I already reviewed with you. There's a video up from Tuesday and Wednesday. Tuesdays for my first period, Wednesdays for 5th, 6th, and 7th period. Okay, but that is what your quiz is over. This will not be on your quiz. All right, but this homework that I'm giving you today will be due on Friday. Okay, so it's still part of this week's homework. It's just that this is not on your quiz. Number one, we're talking today about starting three-dimensional figures, and we're going to go into volume, and if we have time, we'll go into surface area of figures that are 3 dimensions. So think of like a pyramid or a soda can, something like that. It's a 3-dimensional object that you can hold. We have to define a few terms first, and then we will get into, it's not even much math today. We're just figuring out how to create these figures, all right? So we're starting with math terms over here. Excuse me. It tells you what each thing is called. They're going to ask you to draw a net, or they're going to ask you how many faces there are, so you got to know what those things are. A net is a 2-dimensional representation for 3-dimensional figures. So it's like if you took apart the sides of a tin can, for example, you'd have the top and the bottom, and then the part that is usually like that, you'd unravel it, and it would just be like this big rectangle that has been twisted. So this is a net because it shows the shapes that are composed in the tin can, but they've been kind of rolled out to be only 2 dimensions. Okay? The face, a face just means any side, the polygons that make up a 3-dimensional figure. So again, the tin can, there are 2 bases. You could also call them faces because they are sides, but they're more specifically bases, okay? And then one of the faces is a rectangle because it's the part that you unraveled and it becomes a rectangle. The 2 bases are circles. So you're just naming the types of sides there are, or you might even, if there are letters involved, you might name them using letters, okay? An edge is the intersection of any 2 faces. So for the figures 1 and 2, here's an edge, here's an edge, here's an edge, here's an edge. When these are up, they're touching each other, so here's an edge, here's an edge. It's like that, all the sides of the parts of the figure. A vertex is a point at the intersection of 3 or more faces. So here's a point, here's a point, here's a point, here's a point. When all these triangles are up in their 3 dimensions, they will converge into one single point, all right? So any point where 2 edges meet, okay? Or the intersection of 3 or more faces. In an oblique prism, now I don't really go into this. I'll define it, but we're not going to talk about it much. The edges of the faces connecting the bases are not perpendicular to the bases. In a right prism, those edges are perpendicular to the bases. So what that means, kind of, remember our comparison between a rectangle and a parallelogram, where a parallelogram is like slanted and it's in the wind, you know? It's kind of the same thing. So there's an example of it on the next page, but this is for pyramids. Here's a right pyramid where it's standing up straight, and here's an oblique pyramid where it's slanted. So the faces that are up, that converge at this point, are not perpendicular to the bottom base, right? They're slanted from it. But here, these are perpendicular to the bottom base, okay? So that's the difference. Let's go to number 1, sorry. It says build a frame for each model. What I just want you to see, and I'm going to do my best to draw it, but you might even want to look it up later because my drawing is not going to be beautiful. I want you to see what shape these make. So figure 1 has 2 bases that are triangles, and then it has 3 faces or 3 sides that are rectangles. So if I were to fold these up like that, so they would be standing up straight, and then fold these sides together, can you imagine with me what the shape would look like? It would look like this. Here's the first triangle. Here's the second triangle standing up straight. they're connected because it's a three-dimensional shape. So it kind of looks like that. Okay, this dotted line is the one that's on the bottom left of the figure. It looks like kind of like a Toblerone bar. Okay, and this, by the way, is called a triangular prism. And we'll talk more about what it means to be a triangular prism later. Okay, figure 2. The bottom section of this is a square, as you can tell. And then all 4 of these triangles, imagine them coming together and meeting at one single point. This would be a pyramid. Okay. Now it's not beautiful from the picture that I made, but I'm hoping you can tell that this is comprised of 4 different triangles that all fold up to meet at one point. Okay. It's not perfect because the base is not the right. The base is supposed to be a square, and I kind of made it look like a triangle. Let me see. Okay. It is a square, but again, it's not. Ugh. Okay, well, I hope you can imagine with me or like view from my picture approximately what it looks like, but again, I did not do a beautiful job. Oh my goodness. Okay. Number 2, a prism is a three-dimensional solid with 2 congruent, polygonal, and parallel bases. Okay, let's think about that. It has 2 congruent bases. Let's just say that. They're polygons. The bases are polygons. But it's got 2 bases whose other faces are called lateral faces. When it says other faces, that implies that a base is also a face because it is a side of the figure, but the main sides of the figure, which are not the bottom or the top, are called lateral faces. Okay? That is the big difference between a prism and a pyramid, is the fact that it's got 2 congruent bases. All right? So the first figure that we drew here must be a prism because the 2 bases are the triangles. The second figure that we tried to draw, that would not be a prism because it only has a single base. The bottom is the base, the top becomes just one single point, so that can't be a base. All right, letter A, what is the shape of the 2 congruent and parallel bases in the first figure? Well, the 2 bases are triangles, right? If I were to move the shape so it was standing upright, then the bottom and the top would be triangles. Letter B, what is the shape of the 3 lateral faces? Rectangles. I hope you agree with me. Just from the net, just from this first picture they give you, there are 2 bases, the triangles, and 3 sides or faces, which are rectangles. All right, letter C, what is the best name for the solid formed by the net in figure 1? I kind of already told that to you. It is a prism. Okay, it's defined up here. It's got those 2 bases. But specifically, because the bases are triangles, we call it a triangular prism. All right, moving on to the next page. Now we're going to talk about pyramids, and they did a much better job of drawing a pyramid than I did. Please don't judge me. All right, so just as a reminder, the math terms, in an oblique pyramid, the intersection of the lateral faces, the top point of the pyramid, is not directly over the center of the base as it is in the right pyramid. So as we know, a pyramid is defined as it only has one polygon base. That's what it says here. And then the lateral faces are triangles. Think of any pyramid, like the pictures in Egypt that you've seen, any pyramid, it's triangular, right? But the sides are triangular. The base does not have to be triangular. The base can be any polygon. It could be a square or a rectangle, or it could be a pentagon or a hexagon. It could be any polygon. All right, knowing that pyramids are named according to their base shape, and whether they are right or oblique refer to the second tent frame you constructed, or tried to, over here. That would be called a square pyramid because the bottom is a square. I think it would also be a right pyramid because all those triangles, once they fold up, they would have to meet right above the shape. one of them is not longer than the other. As you can see in the oblique pyramid, like this side right here seems longer than that side. Okay, so I think in those kind of pyramids, maybe not all triangular sides are the same because they have to be slanted. What is the shape of the base in the figure that we drew? Square. What is the best name for the solid formed by the net in figure 2? A square pyramid. Again, that's the figure that we tried to draw from the net. All right, we are skipping these, except I do want to point out that the figure shown down here is called a hexagonal pyramid. The reason is it meets on the top at one point, but it's got 1, 2, 3, 4, 5, 6 sides on the base, so it's got to be a hexagon. List the vertices of the pyramid. Okay, remember vertices are the points where the sides touch each other. So A, B, C, D, E, F, and T, because the sides all do touch each other at T. A, B, C, D, E, F, T. Yeah, well, that's what happens. Okay, list the base edges. So not these edges, the edges on the base. So AB is a base edge. BC is a base edge. CD is a base edge. Do you see the pattern? AB, BC, CD, DE, E, F, F, A. Right? Well, there should be 6 listed. 1, 2, 3, 4. Yeah, there are 6 listed. List the lateral edges. All right. If base edges is a category, what do you think lateral edges refer to? The edges that are on the side. The word lateral means side. So these edges right here. TA, TB, TC. Do you see the pattern? TB, TC, TD, TE, and TF. Let me put my little lines above them all. List the lateral faces. What's a face again? It is a side. All right, and it's the lateral bases. It's not, I'm sorry, lateral faces. That means the sides that are not also the base. All right, so lateral faces, they're all triangles. So TAB is one of them. Triangle TAB is the first face. That's this one right here. All right, and then the next one would be TBC. Triangle TBC. Can you name the other ones? Okay, you should get TCD. You should get TDE. What else? TEF. TEF. There's got to be another one because there are 6, right? So TFA. That reminds me of TSA when you go to the airport and they check your bags. TSA. TFA. All right, we are skipping 5, 6, 7, 8 parts A and B. Isn't that nice? All right, not that it's not lovely material, but we've got things to do, places to be, people to see. All right, sketch and label the top, bottom, and side views of this rectangular prism. Meaning, if I looked at it from above, if I had a drone and I was right on top of this and I'm looking down at it, it would not look three-dimensional because I can't see the side view of it. I can't be diagonal of it. I can't see all the things that are happening. I can only see the top. Just like if you were right above a building, right, and you weren't on the side of a building, then you wouldn't be able to see that it's three-dimensional. If I looked at it from the top, then all I would see is this big old rectangle, right? I would see this side right here. And I would see nothing else under it because the top covers every other part of it. That is a really ugly rectangle I just drew. I'm not going to try not to use my tool. So there it is. All right, side views. So bottom, top, and side views. Side views, let's see. One of the side views would be if I'm looking at it from the front, it would look like this slightly smaller rectangle. So this is the front. And then the other view from the side would be this even smaller rectangle. If I were over here looking at it from the side, sorry, here's my hair. Looking at it from the side, it would look like an even smaller one. So side. Okay? All right, now this was an easy one because they were all rectangles. Sometimes they do get slightly more involved. Skip number 10. Number 11, sketch the bottom, top, and side views of a square pyramid. Let's go back and look at a square pyramid, okay? Just to remind us. Look at that one, didn't even have a picture for you, so it's not like I can just look at the picture. All right, if I looked at this from the front, it would be a triangle. If I looked at it from the side, it would be a triangle. But what if I was right above this pyramid looking down at it? Can you see just a single point? No, because if I'm over here and I'm looking down at it, I see, because it's going outward toward the bottom is bigger than the top, right? The top is just a single point and it gets bigger. So I would actually see all the way down to the base, but I would view it as only two-dimensional. I would not view it as standing up tall. So it would still look like the bottom of the base. Where are we? Okay. The top view, I would be looking down at it. It would still be a square because I can actually see all the way down the figure from right above it. But I would also see some jazz going on where I still see the minor details. Like there is a point in the middle of this square. It doesn't look like it's coming up out of the square. It looks like it's flat with the square. All right, and then like we said, the side views look like that, and the front views look exactly the same because they're both triangles. Okay, a cross section. A cross section of a solid figure is the intersection of that figure and a plane. So imagine Fruit Ninja. If I take that watermelon and I cut it with a sword really quickly, and I would make like a little slice, what would that little slice look like? That's a cross section. So just like this, if I took a sword and went wham, and I cut this prism, right, in some part of the prism, the shape that I make kind of looks like a square or a rectangle, right? And it also depends, like if I'd cut it here instead, it would be a rectangle, but it would just be a bigger rectangle, okay? It would look like that. This would be the rectangle that I cut out of it. So it depends on where you cut it. It also depends on whether you cut it horizontally like that or vertically like that. Okay, so we'll talk about that as we go through some problems. Skip number 12. We have one up here, number 14. Use geometric terms to compare and contrast prisms and pyramids. We're going to do the cross-section thing in number 15, okay? So don't worry, we'll get there. All right, so geometric terms to compare and contrast prisms and pyramids. Prisms have how many bases? 2 bases that are polygons. Pyramids have 1 base, right? And then it has some lateral sides, which they both have lateral sides. So I get that's geometric terms. So both have lateral sides because I'm comparing and contrasting. Okay, prisms have 2 bases that are polygons. Pyramids have 1 base. That one's also a polygon, by the way. And then both have lateral sides. Number 15, consider the triangular prism below. By the way, do you agree with that? Triangular prism. It has 2 bases, top and bottom, that are both triangles, and then it's got some sides. How many sides specifically? 3, right? It's got the back side, this big rectangle right there, and then it's got this side and this side. So a total of 5 sides altogether, the top and bottom base, and 3 lateral sides. Letter A, sketch several cross sections that are parallel to the base of the triangular prism. So if I were to go wham with my sword, like in Fruit Ninja, right? And I cut that shape, it would look like this. Wouldn't it look exactly like one of the bases, either base? So that's what it would look like if I crossed it horizontally. And it doesn't matter where I do it. I could do it higher, lower. Because the prism is the same all the way through, it's not like a pyramid where it's different depending on where you cut it. For a prism, I could cut it higher, middle, lower, doesn't matter. If they're all horizontal, then they all look like this. Okay, but sketch several cross sections that are perpendicular to the base of the prism. All right, so what if I cut it wham, like that? That's perpendicular to the base, right? It makes a right angle with the base. But let's see what shape I get. It would look like that, wouldn't it? Okay, so I have this like little rectangle. But what if I cut it further back? All right, what if I cut it here? All the way back there. By the way, this kind of looks like a wedge of cheese, right? If I cut it further back, it actually does get bigger. Or if I cut it further up, it gets even smaller, doesn't it? So I could have this little tiny rectangle. They're all rectangles, but they're different sizes depending on where you cut it. All right, skip letter C. The patterns are part A is all the same. Part B, different size rectangles depending on where you cut it. All right, go down here. This is your homework. Page 485, numbers 16, 17, and 19. So you might notice I skipped 18. Don't do 18. Also, I wanted to look at letter G with you. You have to do A through F. You list all these different parts, and it's great practice, and I like it. But letter G, what is the best name for this polyhedron? Polyhedron, they went through it in the lesson. Just think of it as shape. What is the best name for this shape? All right. Is it a pyramid or a prism, first of all? So you decide that, meaning is it two bases or one base? And then how many sides does the base have? 1, 2, 3, 4, 5. So you have to think of a blank blank, the name of the shape of the base, and then whether or not it's a pyramid or a prism. All right. That's my hint for you for letter G. This homework is due Friday morning by 11:59. Have a good day, everybody.